In this chapter, we'll cover the chemistry of aromatic compounds. The reason why aromatic compounds were named as aromatic is because some of the initial aromatic compounds that were discovered had an aroma associated with them. For example, vanillin, it results in the smell associated with vanilla. Methyl salicylate is wintergreen oil, and there are other examples. TNT, or 2,4,6-trinitrotoluene, is an aromatic compound that contains 3 nitro groups and a toluene molecule. Many aromatic compounds are sourced from coal and other petroleum products. For example, benzene, toluene, which has a methyl group on benzene, xylene, which has 2 methyl groups, indene, which is a 5-member ring fused to benzene, naphthalene, biphenyl, anthracene, and phenanthracene are examples of aromatic compounds that are isolated from coal and petroleum. In order to learn the rules about naming aromatic compounds, it's a good idea to learn some basic parent names in aromatic naming. For example, benzene is a 6-member ring that contains alternating double and single bonds. Aniline has an NH2 group attached to benzene. Phenol has a hydroxyl group on benzene. Toluene has a methyl group on benzene. Benzaldehyde is an aldehyde attached to benzene. Benzoic acid has a carboxylic acid on benzene. And then finally, anisole has a methoxy group on benzene. In order to name substituted aromatic compounds, we simply use one of these parent names and add a substituent based on where they're located in the benzene ring. We can use numbers as we have for other alkyl compounds, or we can use ortho, meta, and para if there are 2 substituents on a benzene compound. For tri-substituted aromatic compounds and those containing more substituents, we always have to use numbers rather than ortho, meta, para. In other words, ortho, meta, para is used exclusively for naming disubstituted aromatic compounds. Here's a few examples of aromatic compounds and how we would name them. The first example has a benzene ring, which is our parent name, and it has a bromo substituent on it, so this compound is named as bromobenzene. The next example has a nitro group, and it has benzene, so this is a nitrobenzene compound. And then the last example is propylbenzene, since it has a propyl group attached to benzene. Occasionally, we might need to give the benzene group as a substituent on a more complicated compound. This occurs often when we have an alkyl group that is at least 7 carbons or more, or we have a perhaps shorter carbon chain that has another functional group that is higher priority than the benzene ring. In those cases, we use the substituent name phenyl for the benzene. As an example, here we have a 7-carbon chain with a benzene attached on the 2nd carbon, so this is named as 2-phenylheptane. Note that the phenyl group is not the same as a benzyl group. They're often confused by students. A benzyl group has a CH2 group and then a benzene ring. Let's cover a few examples of disubstituted benzene compounds. First example has 2 chloral substituents on benzene, so this compound is named as 1,2-dichlorobenzene, or we could use ortho-dichlorobenzene. The next example has two methyl groups on benzene. So this can be named as 1,3-dimethylbenzene, or it could be named as meta-dimethylbenzene, or we could use the letter M in front of dimethylbenzene to indicate that this is a meta-substituted compound. Note that we could use the letter O for ortho or P for para as well. The last example for the disubstituted compounds has a chlorine on the fourth carbon from the aldehyde. So this can be named as 4-chlorobenzaldehyde or para-chlorobenzaldehyde or p-chlorobenzaldehyde. Here's a few examples of tri-substituted benzene compounds and those containing more substituents. The first example has two methyl groups and a bromine on benzene. So alphabetizing these substituents, we would name this as 4-bromo 1,2-dimethylbenzene. We name the two methyl groups on carbon 1 and 2 since they're right next to each other. And then continuing in the direction of the bromine, at least the shortest route to it, to give the bromine on carbon 4. Any other possible numbering method would give or will lead to higher numbers for the location of these substituents. The next example has a hydroxyl group on benzene, so this is named as a phenol, and it has two methyl groups on the phenol. One is right next to where the hydroxyl group on carbon 2, and then the other one is on carbon 5, so this is named as 2,5-dimethylphenol. The last example on this slide has three nitro groups on a benzene that has a methyl group. You might recall that such compounds would be named as toluene, and since we have three nitro groups, this would be 2,4,6-trinitrotoluene. In this question, we're going to try to provide the name, the IUPAC name for the following compound, which contains a benzene ring, an ethyl group, and then two nitro groups. Parent name for this compound is benzene, and it has two different substituents, an ethyl and a nitro group. We alphabetize those two types of groups, so ethyl goes first, and that would be on carbon 1. The reason for that is we have a nitro group next to it, so numbering this carbon with the ethyl group would give the lowest possible numbers we could use for locating the substituents. So this compound would be named as 1-ethyl, 2,4, so continuing in the direction of these nitro groups would give this carbon 2, and then this one 4, so 2,4-dinitrobenzene.